All right, we're back at video 93. Confidence intervals for the difference of proportions.
Awesome! Man, this is getting good.
So kind of a refresher of what we were doing in class today.
Do you remember video 1, by the way?
Just to make, I do.
We've come a long way.
We have.
All right.
All right. So we have confidence intervals. Here we go. So a famous medical experiment was conducted by the Nobel laureate Linus Pauling.
He's the vitamin C guy.
All right. That helps vitamin C right there.
Mm-hmm.
Who believed that vitamin C prevents colds. His subjects were 279 French skiers who were predominantly assigned to receive vitamin C or a placebo.
Why French skiers?
I don't know, because they're up in the mountains where it's cold.
So many questions. Okay.
Of the 139 vitamin C, or given vitamin C, 17 got a cold. Of the 140 given the placebo, 31 got a cold. So we want to kind of figure out the difference of proportion there in our confidence interval.
I love this problem because this is the results of an experiment.
Yes.
Something else we did. So you get the results of an experiment. The natural thing would be to do some sort of testing like this, hypothesis testing.
To see if it works.
All right, this all fits together. Okay.
So so let's do the vitamin C people first, right? So there's 139 given vitamin C. So 17 out of 139, and what would that be, Mr. Miller, who has a calculator in his hand?
17 out of 139 is 0.12.
All right, so 12% got a cold.
0.88.
So that would mean
didn't.
88 didn't. Okay. All right. So there's 144 given the placebo. 31 out of them got a cold, which becomes.
Sorry, Mr. Miller's a little slow today. 0.22.
All right.
And 0.78.
Yes. So our Z-star, we want I think it wants 95% on the second page, if I remember right. So that would be 1.96.
All right, man, get ready.
Okay.
Can you start writing out all that stuff? I'll start typing it in.
So we got 1.12 times 0.88 over 139 plus.
Isn't that cheat sheet beautiful we have for this?
2 times 0.78 all over 140. Take the square root of all that jazz, and what do we get? Sometime this week.
I know. So second square root, second answer. There we go. We get 0.045.
Okay.
We should have a song for this or a way to remember this.
I'll leave you to come up with that one.
Okay.
Maybe like a rap.
Next.
All right.
So the difference in proportions.
So compute the 95% confidence interval of the difference of proportions. So we had 0.12 minus 0.22. Okay, there's our difference of our proportions.
About 10% difference in our sample.
And we're going to plus minus 1.96 times 0.045. So
you want the lower value?
So, yeah, that would be great.
Minus 1.96 times 0.045. The lower value is negative 0.19.
Okay.
Rounding a little bit. The upper value plus 1.96 times 0.045. I get negative 0.012. So we're saying it about in between 1.2% and 19% difference.
Yes.
With the second proportion being bigger.
Mm-hmm.
Okay.
All right. So interpreting, that's exactly what we just said.
You got this.
Right? Wait a minute. You want me to write the whole thing out?
We are.
Good Lord.
95% confident.
We are. Figured the kids would have this down by now. Confident.
In the interval. That the interval.
In the interval.
No, that the interval.
Oh, you know what?
I was just emphasizing word confidence in the interval.
Okay. That the interval which is negative 0.19, negative 0.012, contains the true difference. It just looks like a bunch of scribbles. The true difference in
proportions
proportions
of people who got a cold.
of colds. I'm not writing the whole thing.
Wow, good job, Mr. Lewis.
Yeah.
All right. Use your TI-84 to get a 99% confidence interval. I don't know if I
Okay.
remember all the numbers here.
I think it was.
So you gotta go stats,
Yes. Stat. Test.
test. You gotta remember
B.
B. How
Yeah, we
we
want two
gotta figure out how we're
sample.
gonna remember this.
130.
Two proportions, that helps, and it's a Z interval based on the normal curve.
Right.
So the first
And-
thing you need to know is X1.
And it was, I think it was 17 out of 139.
I hope so. 139. Okay. So you need X1. So X1 is 17.
Oh, I'm writing the whole thing. I was just going to write the interval.
Okay. What was X2?
Okay, I believe it's 31 out of 140. That one I know is right. The other
Okay.
one, half.
We want 99% confidence interval. It sucks getting old sometimes. What I hate is if you press enter twice, it disappears. So,
Don't change anything.
all right, from negative 0.21.
Oops, 0.21. This is supposed to be a 0. 2.
Positive
Oh.
0.016.
Point.
All right, so maybe real quick, let's just write B2 prop Z int. So this
B.
is test B, or under B in the list.
2
Proportion
prop Z
interval.
int.
All right,
There you go. So, which one was wider?
99%.
Oh, yeah.
More confidence takes a wider end.
Yep. That's easy to know. 99.
Okay.
All right.
You know what time it is?
It's journal time.
Oh yeah.
So, we have an annual poll of sleeping habits of Americans found that a random sample of 158 Americans aged 18 to 29, 35% slept 8 hours or more on a weekday. Of a random sample of 435 people aged 30 to 64, that's a much bigger interval of people.
Yeah.
36% slept 8 hours or more on a weekday. We want you to compute the 95% interval for P1 minus P2.
Yeah.
And then interpret the results.
Okay. There's one little thing we should talk about. Do you think they should use they can do it by hand if they want. It's set to go by hand. But if they use a calculator, what's X1 and X2?
Well, you're probably going to have to figure out what 35% of 158 is.
True. And I'm not sure the calculator lets you enter a decimal, so you may have to round that. Like if you find 35% of whatever that number was, and it's a decimal, you probably have to round it.
Well, you should always do that anyway when you're talking about people.
Yeah.
Because, I mean, you can't have 0.4 of a person.
In horror movies, you can. In Saw, I believe that happened.
Yeah. But we're going to get out of the Texas Chainsaw Massacre and deal with whole people.
Yeah.
So
So anyway, just so you know, so you got to find X1 and you have to round.